Hi guys, I have started this series Applied Data Science to break down fundamental skills you need as a data scientist. I won't focus on fancy machine learning algorithm. This video defines how to be a business translator, able to navigate business levers and drives, and create meaningful value. I will use Uber as a practical use case to show you how to make millions from a single feature on the app alone. Let's get started. So the first thing we need to distinguish here is the translator mindset. There is a big difference between a junior mindset or a junior data scientist versus more experienced data scientist. The first one is focus on technicality, data cleaning, model training, model evaluation. Assume Kaggle datasets are the norm. Experienced data scientists identify users' needs, translate business goals or KPIs into actionable metrics, map data to profit margins. We have two types of business levers and business leverage. So when it comes to business levers are actionable variables or metrics you can adjust to level up your business performance. Changing the cost of your product is a business lever, as an Uber search feature. And I will break this impressive concept in action in the following slides. On the other side, we have business leverage. The effort and amount of products are fixed, but you multiply your output by adding more dollars from investment, as an example, or hiring a senior for a junior position and pay him the small salary that's dedicated for this junior position. There is a risk for this practical example, hiring a senior for a junior position, in that he becomes the unicorn. And this is a labor leverage. The company saves money as he uses his practical experience. On the other side, during this fulfilling the position, ad hoc tasks and his expertise to provide more value to the business, there is a risk that a significant chance when he quits as soon as he gets better offer. There are types when it comes to business leverage, such as money leverage, labor, technology or software, etc. Then we have human and physical leverage. So human, when talk about it here, how Uber dedicate its algorithm to understand and affect riders' behavior. So let's start by defining and analyzing this much further. Let's analyze Uber organization. Uber is an app that connects drivers to riders in exchange for the percent of the fare. Uber doesn't have cars to operate. It's just an application and a complex software that navigate the routes, the riders and drivers' profiles. So this is business or physical lever. Uber technologies, contact with the drivers, research team, Uber offices. On the other hand, we have the human lever. This can be addressed in another story, is like how Uber dedicates its algorithm to understand and affect riders' behavior. The law in demand popular graph is flexible with analyst needs, and there are products that are expensive and still popular, and as we will see in the next graph. So the law of demand, we have on the x-axis we have the quantity demanded in millions in this graph, and on the y-axis we have the price in dollars. So we can see that if the product is 3,000, there is 5 products, like the sales, and if it's like 4,000, it will be 4, and 2,000 it will be 6, right? Because this is the demand curve. You might think that we as engineers, we don't have to get in depth with the law of demand graph or understand this finance graph, but to reinforce your knowledge in business in order to help you understand the invisible patterns of the user's spending and the interaction with the system, it's so important to understand this business side. Theoretically, when the price is low, the user is ready to spend more on the product and service. I like to think of this graph, the law of demand, not just as cheap products and services, but as a change in the price. So for an example, if the product costs 3,000, right? We have the prediction that it will be 5 products will be sold. But what will happen if we made a discount for certain users, and instead of spending 3,000, they now can spend 2,800, for example. If that will give us or lead to more sales, we can go from there. So the law of demand graph is flexible. It covers the needs, and it can help us to understand more about the users versus the sales we make. Let's try to emphasize that on the Uber use case. As you can see from the right side graph, we have the price and quantity, but there are more features added to this graph. So the baseline, we have the original demand with divided with B, the D line, and then we have the B star, the base price, and we have the Q star for quantity, right? And they are meet on the E point. When a rider orders Uber trip in XYZ location, initially the ride fare is fixed. Let's say 15 pounds. And this 15 pounds reflect the distance versus time of the fare of the trip itself. The driver receives the notification and he go to the rider pickup point to start the trip. Imagine the driver is 3 kilometers away from the rider pickup point. Those 3 kilometers are empty kilometers, as Uber won't include them in the fare. Let's assume that there is more riders in this XYZ location. Uber is worried that more drivers cancel the rides. So it activates surge feature by 15% on each trip. Instead of paying 15 pounds, the initial fees, you will pay 15 pounds plus 15% of the total fare. The riders get the notification that the fare has been increased by 15%, the surging price. So this is the shift factor, the D dash. So D dash that meets with the P dash, the new fare, base fare plus the surge, 15%, and the Q dash, the number of accepted rides, okay, ready to pay the fare after the surge. And they are meeting on the E dash, okay. So we can say here that human lever is for the rider point of view. Will the rider wait 10 to 20 minutes for the price to drop, or aka the price elasticity, practical concept, or rider will still confirm the ride and pay the 115%. This is a new concept, the price elasticity, that's related or connect the law of demand graph and the business use case Uber. So based on that, we have 3 categories. The number of riders that will still accept the ride or accept the new fare, 115%. And we have a new category, the number of rides that wait for 10 to 20 minutes before making a new request. And finally, number of riders that forget it, I will walk and close the Uber app. So the business factor here for the first category is maximizing the profit by 115%. We also measure the conversion rate, and we have the price elasticity threshold, finding the exact price point where profits from the surge are whipped out by riders leaving. Is it like 15%? Is it 16%? Like it helps the Uber to adjust the price threshold later. Then second category for Uber is the survival analysis algorithm, to measure how long an app stays open or how quickly users reopen it. And we have another good indicator that demanded postponed to understand if the surge is actually clearing demand or just delaying it a later time window. And finally, for the last case is the churn rate. Another good example when it comes to Uber elasticity or price elasticity, there are determinants of price elasticity, characteristics of price elasticity that we can talk about. With the wine sales, we are having 2 categories here for the wine sales. But first, let's define price elasticity in more details. So price elasticity measures how sensitive the quantity demanded by a product or service is affected by the price deviation, holding everything else constant. In the wine example, the uniqueness and the prestige determinant, we have 2 categories. High-end wine bottle in elastic versus mass market wine bottle, elastic. So the first category, the high-end wine bottle, such as a bottle defined by its year, origin, and specific grape ingredients. If the winery increased the price by 15%, still some customers will buy it because the year, the origin, the specification of the wine ingredients. So as you can see from the graph on the right, if the company increased the wine bottle instead of 90 to 100, the people will still buy it. Some of the customer will still buy it. On the other hand, we have the mass market wine bottle, is that conversely, a basic table wine with no unique origin has high elasticity. If the bottle price goes up by 15%, consumers will instantly switch to the bottle next to it on the shelf. And this represents the first characteristic of price elasticity, the uniqueness of the product and the prestige. A second beautiful use case is perfumes versus dupes. Substitutability. So price elasticity here, how easily a consumer is ready to go for an alternative product or a service that's more affordable. We have here two examples. The price elasticity is here, how easily, yeah. So the dupe effect versus original scents. Historically, luxurious perfume companies enjoyed relevantly inelastic demand because of brand status and potential legal procedure. But with the advanced technology and exploiting or cloning the original scents, and at the same time avoiding trademarking names and packaging, it becomes a rabbit hole. So dupe is replicated formula, more affordable in different package. This is elastic, and original scents are inelastic. There is actually a great article. It's called Perfume Brands Fighting a Lost Cause Against Cheap Dupes, Say Lawyers. I will add the link down below. So the dupe have fundamentally shifted the original perfume's elasticity. A relevant example, laptops, product specifications and switching costs. Hardware specifications, brand status, and ecosystem architecture that influence laptop price elasticity. So we have Apple, highly inelastic. We have Lenovo, highly inelastic in business to business. And we have Dell, HP, etc., highly elastic. So let's make this comparison between the three categories. We have Apple that doesn't just sell RAM or screens, they sell ecosystem, iOS, iCloud, iMessage, FaceTime. This creates massive switching costs. If Apple raises the price of a MacBook, users don't easily switch to a Dell because changing their entire digital workflow is too painful and expensive. We have also Lenovo ThinkPad inelastic in business-to-business market. So ThinkPads have a legendary reputation for durability, specific enterprise IT compatibility. A corporate officer might be completely insensitive to a price increase because the corporate infrastructure is built around ThinkPads. So Lenovo won't be replaced. Apple won't be replaced. On the other hand, the last category, the Dell, HP, etc., the other brands, if you are looking for a mid-tier Dell versus mid-tier HP with identical hardware specification, such as 16 GB RAM, 512 GB SSD, they are identical. So if the Dell decided tomorrow to raise the price by 200 euros, the consumer effortlessly switches to HP. What we get from all these characteristics of price elasticity is that as a data scientist, you usually want to move the product of the company or the service from elastic to inelastic feature. Cannibalization. I like to finish this video with a beautiful quote. If you don't cannibalize yourself, someone else will, by Steve Jobs. It's a great story. I highly recommend it to check it out. It makes the classical tech example between iPhone versus iPod. This is like a gold standard of cannibalization. And Steve Jobs introduced the iPhone in 2007. The iPhone completely killed the iPod, which was Apple's biggest profitable product ever. And that's it for today. Thank you so much for watching my video. I enjoy building this series and highlight the critical business skills that a data scientist needs in his toolkit. Don't forget to subscribe, share, and like my videos, and I see you in the next video. Bye.